Thank you, Melissa. And Arlene's presentation was, I found 3 hooks in there that connected to what I'm going to present today. So hopefully we can pick some of those up. Just one slide just on the technical side. Just the difference in terminology between interlocking concrete block pavers and permeable pavers. The terminology is terrible in Australia and incredibly complex, but I want to pick up one of the points Arlene made, and that is we're not always trying to pave the world. Quite often in these systems you'll have some hard standing areas that are not permeable or not even pavers, perhaps asphalt, and then you might have an area that you want to drain onto your permeable pavers that might be interlocking concrete pavers, but they're not permeable. And then you might just end up with your most downstream part as being permeable pavers. So I just wanted to explain the difference between them because they are fundamentally different. And I think a lot of the early mistakes that were made in Australia, systems I've seen that are not performing today and perhaps are clogged today, are because people were sometimes designing both these and getting mixed up. So I have seen permeable pavers go down onto sand, for example. You should never see sand anywhere near a permeable pavement system. They should be bedded on, as Arlene said, 2 to 5 or 2 to 6 mil gravel. But you always put interlocking pavers that are impermeable on sand. So the contractors do way more of those than they do the permeable pavers, and they get used to it. And it's tempting for them just to roll more sand out and put the pavers down as well, without not putting contractors down. But I've seen those types of mistakes go. And the resistance, another point that Arlene made is the resistance that you get from consenting authorities like councils. A lot of councils just will not allow you to put permeable paving down because they've seen these systems fail. I'm saying they've seen these early systems fail. I think the designers today that are using more sophisticated design tools like the Design Pave program are doing things much, much better than we were doing even 10 years ago. And the systems today are performing really, really well. And you can design a system, a permeable paving system, to fully clog over its life of 25 years and it will still meet its design standards for that full 25 years. It's not difficult to do. Okay? So I just wanted to explain that terminology and the difference between them. Something else Arlene mentioned, but only briefly in passing, was, I should be able to use a pointer after all these years. No, I can't. I'm colourblind as well, so I can't see red. This edge constraint is very, very important. Whether you're dealing with permeable pavers or interlocking concrete block pavers that are impermeable, they both do the same thing, and Arlene did touch on this, they lock. They're designed to lock. And they lock through some horizontal forces that happen through rotation and wedging, fundamentally. That all falls over, doesn't work, if you don't have good edge constraints in. The whole point of the locking and the rotation, working together to lock, is that they displace each other very, very slightly at the beginning, and they try and push the pavers out. And if you've got an edge constraint, that locks the whole thing up, and you get almost like a slab. And it works really, really well in sharing the load. And you can put very, very heavy loads, as Arlene finished the presentation on, onto these systems, but not if you allow their lateral movement. So that is actually a very important design component, those edges. Very, very important indeed. Okay, so I just wanted to touch those. That, by the way, I'll be testing you on later, so look at it carefully. That is a simple flowchart, and that is the simplest flowchart you can have for designing an interlocking concrete block paving that's not permeable. Now you can see why CMAA invested in Design Pave, because that is a push of a button on Design Pave, but it's not if you're doing it by hand. And that's another constraint that I think CMAA has been very smart in removing. It's removed the complexity, it's allowed the engineers to focus on the creativity, because all the mechanistic design is done by software these days. And if you haven't downloaded that software, it's free of charge, and it does both the permeable and the impermeable, both the hydrology and the geotech stuff, all in the same program. Okay, so that's the Design Pave software. Quick plug for that. It's incredibly popular. I think Elizabeth was saying to me 670 downloads so far, 690 downloads so far. As I said, free of charge. Have a play with it. It's incredibly simple. It's the most sophisticated paving design software tool in the world today. Okay, Australia is at the forefront with this software now. It was developed at the University of South Australia, but under the sponsorship of CMAA. My colleague, Associate Professor Mizan Rahman, was the principal author of that software. Melissa's asked me to talk, Arlene's focused very much on Australia. Her final slide was from Staten Island in New York, but fundamentally she did a great job in showing how recent developments have occurred in Australia. I will have a few Australian systems I'm going to present, but I'm fundamentally going to walk you through the history of these systems overseas. And there's so many lessons to learn from that, from the early pioneers to when Australia got involved, and what drove things and what stopped things happening. Why has Australia fallen behind some other countries, but why are other countries doing things still very badly? Melissa mentioned about the geofabric being no longer necessary in Australia, and there's a very fundamental engineering reason for that, but nobody talks about it. So people are confused about whether they should be there or shouldn't be there, and I'll try and, through these case studies, just talk you through a few of those. Okay, so really it's kicked off in Germany and Austria, and those two countries today are still world leaders. They do things very, very well. Their designs are excellent, and you'll see more permeable paving, particularly in Germany, than pretty much anywhere else in the world. If you ever have a holiday to Germany, have a walk around, you'll see them everywhere. But they also use a lot of interlocking concrete block pavers that are not that are impermeable. But their design methods are superb. They are one of the co-developers of the machines that lay the slabs 1 square metre at a time, which vastly improve or reduce the cost of a project and increase the speed of laying. And I'll give you some speeds in typical projects as we go through them. So Germany and Austria, worth looking at. Belgium, on the other hand, went down a completely different path. In Belgium, they add cement into their base course material. So they can use permeable paving on moderately high-speed roads and very, very heavy applications. But you don't see cement being added very often in Australia or in many other countries in the world. So be careful when you look at a Belgian system. It's very differently designed, but very much backed by their government. They've got a national design centre funded by the Belgian government purely for paving. Okay? So Netherlands also put a lot in, not to the same extent as those other countries. The UK started very slowly, but then really took off. And what happened in the UK, and this picture is the same in the USA as well, is a top-down approach. In the UK, you cannot put in an outside car park for a Woolies or a Coles or what they have as Tesco's. You cannot design one of those, or a hospital car park, unless it's permeable. You have to demonstrate why you're not putting a permeable system in. Whereas it's just the opposite here. You have to fight nail and tooth to try and get a permeable pavement system in here. In England, it's a top-down approach, and the USA is the same. And the USA is also driven by its EPA, who really pushed the stormwater agenda from a pollution control aspect in the 1990s. And they have more, I've just listed some of the things that developers and designers have to consider when designing in the USA. So they've been very proactive. I don't actually think their designs are any better. In fact, they've got some faults with some of their designs in the States, which have flowed on to South African practice as well. So for instance, they use very large base course materials compared to what we use, up to 50, 60 mil sometimes. They were one of the first countries, though, to do away with that upper geofabric layer. So they did their research and worked out that that wasn't necessary. But the reason, and I'll come on to that point now because it's a very important one, the reason that geofabric layer is almost redundant in Australia is the materials we use in our base course and our bedding material are close enough together. There's a 1:10 ratio that dam engineers use. They're close enough together that there is no natural migration of the bedding material into the base course. That geofabric was first put there because in places like the USA, where they had 50, 60 mil aggregate at the bottom and still the same bedding material we're using, it used to migrate down because the ratio between those two sizes was too high. We've kept that legacy going for no good reason. We think it's still necessary. It's not. It acts as a slipping plane, acts as a clogging layer. There's not many good things about it. Geofabrics are wonderful, and quite often you want to put a geofabric around the base of your system. They are really advanced materials, really good, but they're not necessary, and in fact, I think detrimental if you put them in between the base course and the bedding material, providing you're not using large aggregate stone in the base course. If you are, then that's a different matter. You might need to consider it. Okay. The Australian market, as opposed to all those other markets I've just shown you, has taken a bottom-up approach. It's been people like Andrew King and others, and Tim and others, that have promoted things from a groundswell, and then governments have responded. It's been nice to watch, but it's been so painfully slow, quite frankly. It should be the government taking responsibility. There's many reasons you could say for that. It could be that Australia, as a a fast-growing, population-wise developing country that has to build houses to keep up with the population growth, doesn't want to put too many impediments in the way of developers and builders. Controversial statement, but it's something I actually do think's happened. Bottom line is, governments at some point have to wake up and take responsibility. My experience with developers is they are incredibly proactive, they're incredibly aware of environmental issues, and they are perfectly happy to take on new designs and innovative designs. All they do is they pass that cost on. So they're quite happy to do it as long as they're clear. What they don't want is risk, that it's not going to get approved and that it's going to increase time and things like that. If you can manage their risk for them, they're very happy to be innovative. That's my experience with developers. So I think the government's actually got it wrong. I don't think it's an impediment to developers. The developers would take it on. I just think the governments haven't been brave enough to take a top-down approach. I can say that getting to the end of my career, but that's what I feel. Okay, so even though we were pioneering in research, a chap from the University of New South Wales, Professor Brian Shackle, wrote the Lock Pave program. One of the first computer programs for this type of paving, his original one was for impermeable pavers. He then worked with our university to develop Permpave, and those two have now been integrated into a completely different software package, Design Pave. But we were at the forefront. We have fallen far behind because of this bottom-up approach. Okay? We now have the best software design tool in the world. I think there's a groundswell from the bottom up, which is great, but we still need governments to take responsibility, I think, in Australia. Otherwise, we're just going to keep falling behind. I'll take you through some international, one from Europe, I think 3 from the USA, 3 from South Africa, and I'll finish with 4 from Australia. So Vienna Football Park was one of the very first huge developments with permeable paving. It was called the Prater Stadium at the time, but it's changed its name since then. It was installed by machine back in 1990. That was incredibly innovative at the time. Machines that I use quite frequently nowadays, but at that time, that was very, very innovative. And the area was huge, 39,000 square metres, still very large by today's standards, and still functioning well. All of these are still functioning well, by the way. Chicago White Sox was also a very innovative development. It had a lot of problems as a design. The permeable system was part of the system. This is what I was talking about, where you can put interlocking impermeable pavers next to permeable pavers, and this stadium does it very well. But they did want to pave the world, and they designed this to take the 100-year design storm, okay, as a paving system. It's one of the very few systems I've seen in the world that's gone to that extent. So that's one of the reasons it's so large. You probably would not choose to do that. It's a very expensive option to do. But when you do look at the costs, it's very interesting. So I'll just take you through. There's one of those early automatic machine layers. They're much more sophisticated and faster than that was now. But even then, 1,900 square metres a day. It's pretty productive and pretty cheap. They have a 350 millimetre deep base course, which is quite deep, even for such a large system, and that's because they had to take buses and heavy vehicles as well as cars. And you can see that large diameter stone in there. Recycled concrete is something we wouldn't recommend generally. We've done some research on this, and recycled concrete in your base course tends to leach out calcium, which precipitates and in a permeable system, might be all right in an impermeable system, but in a permeable system, it leaches out calcium and it causes clogging of the base course. It's about the only thing that will ever clog a base course, actually. The fine particles that come in with the stormwater don't reach the base course. But you can see the very large diameter stones that we wouldn't recommend in Australia. That's the type of situation when you'd need a geofabric, because your bedding material would migrate into those big voids between them. Okay, 500,000 permeable pavers we used, which is quite incredible for the time. And as I said, it was designed to meet the Stormwater Management Ordinance of the time, which is 2008, a 100-year ARI rainfall event, which you would never do today. But the cost is interesting. $3.8 million, that was at that time, not today, in today's cost, but it's still quite reasonable. But interestingly, it was almost $500,000 cheaper than if asphalt had been laid. And the reason was there were no pits and pipes. And this is a message I'd like to get across as well. The biggest cost in any major car park or even a lot of road drainage design, your biggest cost quite often is your pits and pipes. If you can design a system that has no pits and pipes, the cost saving is enormous. That's what a permeable paving system offers you. Doesn't mean you have to put permeable paving system over the whole car park. You could have 3 rows that are impermeable, with pavers preferably, but if not with pavers, even with another surface. I'd air you to think about alternatives to asphalt, because asphalt's got the worst albedo, and urban heat island effect is a major contributor, probably the largest contributor to our urban heat island effects. Albedo of asphalt is 0.1. Albedo of permeable paver or an interlocking concrete paver is 0.25. Albedo just means reflectivity of the sun. 0.1 basically means it just heats up. Okay, so don't do that. But sorry, getting a bit lost with that one. If you can design a system without pits and pipes, the cost saving is enormous. Okay, and that's what either an interlocking concrete permeable paving system or permeable paving system offers. So $500,000 cheaper than an asphalt car park, that one. Morton Arboretum in Lisle, Illinois. This is not quite so large, 1.6 hectares, and they had regular interlocking concrete pavers. The cost at the time it was constructed in 2003 was $1.05 million, and again, a full life cycle cost comparison showed that it was less expensive than the equivalent asphalt car park design. I haven't got a slide in this presentation that I have in a lot of my presentations, but it points to a really important research study that was done in 2006 in the UK, where they took 250 constructed car parks and paved systems, basically, but paved projects, and they redesigned all 250 3 times. One for asphalt, one for interlocking concrete paving, and one for permeable paving. And they added up the costs of those. And with a 5% discount rate was the only time that asphalt came out marginally cheaper because the install costs were cheaper. Any other, sorry, no, I got that the wrong way around. Sorry, 15% discount rate was the only time asphalt came in cheaper. 10% and 5% permeable paving and interlocking concrete paving were both way, way cheaper. And that's because designers only include, when they spec up, their construction costs and the design and construction costs. They don't spec up whole of life costs. When you do a whole of life cost for any system, it's cheaper to put in paving systems. Okay, 206, Interlocking Concrete Paving Association UK 2006, it's freely available on the web, 250 projects redesigned. Have a look at it. This is more of the same project. Again, look at the size of that base course material going in. It's huge. We'd never do that in Australia. That's the reason the geofabric came into, one of the reasons the geofabric came into popular use. I'd dare you not to use that system. But still very innovative at the time. Yeah, base course depth was fairly shallow, which again is very strange with such large base course, but anyway. And they included biofiltration systems in that one as well. Howland Hook Marine Terminal, that's exactly the same photo that Arlene had actually at the end of her presentation. What I would point out in that is how many of those containers are sat there? 4 high. Imagine the corner load if a crane picked one of those up and dropped all 4 down on one corner of that 4. Imagine the crane that picks those up and its wheel loads, right? This system is still working perfectly well today, has no rutting, it's incredibly heavily designed, and by the way, Design Pave includes the British Ports method, which is the heaviest design method for industrial paving anywhere, and that's fully incorporated in Design Pave. So you could design that system using the software. I think you come up with a slightly different design, but you could design it, okay? So there is nothing to stop. This is another perception, another myth. Permeable paving systems and interlocking concrete paving systems are incredibly strong. And the reason they could be made strong enough is you just go deeper with the base course. And the load sharing I was talking about at the very start of this presentation just distributes that through the base course. These are made of solid stone. They're not going anywhere. Okay? And if you use a proper design tool like Design Pave, it will make sure you don't under-design. I have too shallow. So this is a very heavy application. It had a very large, very deep base course. But that's all you need to do. There's a cross-section of some of the, it varies across the thing because only certain areas you have the cranes and certain areas you have the containers. Other areas might have just residential, well not residential, but commercial and industrial parking. So it varies across the design. And that's what it looks like today. It has a 20-year service life. Some of the statistics are in there. The wheel axle loads are 97 tonnes. The stacked containers are 23 tonnes at each corner. So don't let anybody tell you that you can't have a paved system in a heavy industrial area. I've seen them in airports, not on the aprons, but on parking areas. I've seen them in container yards. Australia's got its first container yard that's got, well, as far as I'm aware, it's the first container yard. The IMEX import-export facility at Moorebank is now being designed with permeable paving systems. So don't always think just residential and light commercial with these systems. These systems are very, very strong indeed. So they can have much larger industrial applications. All right, I'm going to just go through a couple of South African ones. And I've been to South Africa with Brian Shackle to give some workshops to try and promote good design. And I was a little surprised, to be honest. They are very, very good engineers in South Africa. They're very well trained, but their practices in permeable paving in particular, but also interlocking concrete paver, have been inherited largely from the States. The States have moved on and improved their design. South Africa hasn't. So you'll see some systems here that you would never put into the ground in Australia. But I just wanted to show you that a country that's quite poor and developing is still investing in what they see as good environmental management, and that's to be heralded. Okay, so this is the Reeds Fairland, which was a housing estate, affordable housing estate, which we could do with some more of those in Australia actually. 89,000 square units, covered an area of 4,320 metres squared. Look at the size of the aggregate again. That's American practice. They still use that today in South Africa, and because of that, they still use upper layer geofabrics, which you'll see, I think, you might see in some of these photographs. And they need them because of their large aggregate sizes. Okay, so 80 mil as a coarse wash. Sorry, not 80 mil. Where was it? 160 mil stone. You just would not design with that. And look at that practice, bedding it on sand. That's what I was telling you before. Again, that will clog within a year. You bed permeable pavers on sand, it will clog within a year. Okay, 2 to 6 mil gravel, well designed, 25 years. Okay, that's the finished product. This is my favourite. Talk about not wanting to pave the world. I took this photograph, and Brian Shackle's in the background if you look carefully. This is one of the largest paving systems I've seen. That paving system looks huge. Can you see the barrier at the top? That's another car park exactly the same size as this one. Okay, there's 2 car parks, 100% permeable paving. Got to be, you know, it's wonderful, but totally unnecessary. At least 3/4 of that car park could have been impermeable pavers draining onto permeable pavers. Okay, but still functioning very well today. That will never clog because it's just so large. If it clogs, what will happen is you'll get a wetting front and a ponding, especially a flat one like that, and it will just aquaplane over to where it's not clogged, and it will just keep doing that until it finds a way out. So that will last forever, but it's hugely over-designed. Wasn't designed with software. They didn't have software at the time, so it's lessons to be learned. Again, too much sand on that construction site for me. That's Durban North Kensington Drive. That does have a combination, so to be fair, that might have been where they put the impermeable. Those look like impermeable pavers to me there. But there is a lot of impermeable paving because this is the first water reuse project in South Africa, and this was back in, I think, 2008, I think. Might have been before that. And that's the finished product. Also innovative that they're using trees in association with permeable paving. That's something we wouldn't have been doing probably back in 2008. So there's a lot of innovations happening, a lot of improvements required for South Africa. So this is Smith Street, Manly, which is a retrofit, very early system. This is a very good project. It's not a very well-designed project, quite frankly, but that's because the designers at the time didn't have much to go on. There wasn't many good design guidelines, whatever. What this was good at was convincing people that permeable paving is a good thing. This is one of those early championing projects where, and you talk to the residents, there's been papers written on the street, the value of the houses in that street being higher than, Manly's a very expensive suburb anyway, but being higher because of the environmental management that went in there. So this was a very good community-based project. It's not a well-designed project by today's standards, but as far as I'm aware, it's still working. You can see geofabrics there that aren't necessary, but this is a very early one of the first ones, 1997, the PICP in Kiama, in New South Wales. It's used a lot in coastal environments. This is the one that Arlene mentioned, the Olympic Park, still one of the largest permeable paving projects in Australia. It's one of my favourite projects because you can walk people around and show them about 6 or 7 different types of permeable paving design. It's got just about everything that was available at the time there. And it's a very, very clever use of colour as well, and it's a very beautiful site actually. If you like things paved, I mean I'd like to see a few more trees, but if you like things paved, it is a really fantastic site and still well functioning today. That was a highly contaminated site, highly contaminated site, and yet they still managed to put permeable paving in with linings and other things. So very innovative for its time, a championing project again. Notice though, sorry, going back, even then we were using the right type of base course. 20 mil is pretty much what we use today. Very good uniform grade for permeable paving in particular, and we've been doing that well for a long time, a selection of base courses. These are just examples from Olympic Park. I'll finish with one in Grange, just a tiny one. I had this on the first slide. You can see the edge constraint I pointed out before. I like this one because it shows the top left-hand picture shows the base course, which doesn't look that large. It's not. It's 20 mil limestone, that is. Dolomite, I think. Then the bedding material, which doesn't look much bigger, and it's much smaller, and it in fact isn't, and it's designed to be like that. It's that one's 2 to 6 mil. 2 to 5 or 2 to 6 is the standard specification. And then you've got Eco-Trihex pavers on the top, and there's the finished product. Very innovative design, this one, because it's got, you can't really see it in that photograph, but it's actually dish-shaped. And a permeable paving system, the way it will work, from the way hydraulics works, you'd actually get ponding in the middle if you're not careful with that quite regularly during storm events. It will quickly dissipate, but that would be the area that will clog first, that middle bit. You don't want that bit to be the first place to clog, you want it to be the last place to clog, because if that clogs, you'll get permanent ponding there. Okay, so the designers took a very innovative approach with those lips. You can see the black marks there to keep the water from doing exactly that. So it's a very innovative design, very small, tiny design, but very innovative at the time. And that's working well today. Notice though, sorry, just to go back a step, 5-year ARI is not untypical. You might go to a 10, you might even go to a 20, but you'd never go to a 100-year, which is what that Chicago box stadium, White Sox Stadium, sorry, was. Okay, so I had to rush through that, I'm afraid, because I wanted to cover quite a lot there. Hope that was informative. I think it reinforced a lot of what Arlene was saying from Australian practice. My summary is that we are in a really, really good position in Australia, and I am just fearful that we'll do what we did 20 years ago, where we right at the front of the pack, and then we fall behind because there's no impetus from government. Thank you.
Hello. So when you're comparing sort of some of these permeable pavers to other surface types, has there been research done on runoff coefficients?
Runoff coefficient for asphalt is close to 1, but for permeable paving, yeah, you don't actually have to consider runoff coefficients per se. The only time you'd consider runoff coefficient in a permeable paving design is if you're actually trying to achieve what's called run-on, and run-on's where you might have hate to say it, asphalt or some other impermeable surface upstream of it, and then you have run-on onto your paving system. That's when you'd have to do a hydrological design to see how much extra flow. And there's a ratio of about 4:1 we use. If you try and that's not for hydrologic reasons, by the way, if you try and put 4 times as much impermeable upstream of a permeable, sediment load wise, you're bordering on overclogging. So you probably rarely go above 4:1, and that's when you do those surface hydrology calculations to see how much extra water is going on as opposed to the incident water that will fall on your pavers as well.
I do. So for a lot of the stormwater hydrological designs, we use drains. Is there a way to sort of, I think you mentioned design pave as well, is there a way to sort of account for this, I guess, in drains?
Yeah, no.
accurately?
Drains is written by Jeff O'Loughlin. I used to work with Jeff in Sydney. Excellent stormwater program, but it's not designed for, or at least last time I looked at it, it was not designed for permeable paving. So there's no easy way of modelling it. And I would argue, why would you, when you could just jump over, use the design pave, and then whatever flows you've got. Because I haven't touched on this. I sort of probably gave you the impression that permeable paving is only good for holding on to water on the site. There are some sites where you don't want to hold on to the water. Arlene did mention this, where you might either have partial drainage out or even sometimes full drainage out. You infiltrate in and then collect it with a pipe. That's when you enter hydrology design, that you'd need to then jump over to a program like drains. I'd err you not to jump over to music. I'm not a great believer in the hydrologic accuracy of music, but something like drains would be probably good for that, because it's fundamentally dealing with pits and pipes after that.
Okay, other questions?
Is there an Australian standard, and if not, why not?
Elizabeth. No.
Repeat the question, please.
Yeah. Okay. The question was: is there an Australian standard on paving? And the answer is there might be one on the structural side. I'm a hydraulic engineer. Certainly isn't on the hydraulic side, and it's a very good question. Why isn't there? I don't know.
There's quite a few gems in there, that little rules of thumb that I think we all probably needed to hear. So that's great.